Greetings and welcome once again to my new calculus channel. I'm John Gabriel, and today I'm going to talk about several ideas about the concept of number and who came up with those ideas. And then I'm going to grade them. So I'm going to give them a grade out of 10. So let's begin. Now, Newton saw numbers as measures of quantities and closely tied them to geometric and physical magnitudes. In Universal Arithmetic, I think that's one of his publications, he treated numbers as ratios of quantities and emphasized their practical computational use. He did not view numbers as purely abstract entities, but as tools for describing and analyzing nature. So I give Newton a grade of 5 out of 10. Why? Because numbers are really names given to measures of quantities, but Newton didn't understand that quantities are not numbers, so he had a bit of circularity. And also, he missed the point that numbers are purely abstract concepts, not just tools for describing and analyzing the physical universe. Numbers are names given to the ratios, given to a measure that describes a ratio of quantities. So that's why he gets 5 out of 10. Then, Leibniz saw numbers as expressions of order and harmony, grounded in logic and combinatorics. He emphasized their role in calculation and symbolic reasoning, advocating for a universal mathematical language. He explored binary numbers, viewing them as fundamental to arithmetic and logic. He was wrong, totally wrong. I would just give him 1 out of 10 because he mentioned their role in calculation, but he missed the point entirely. So he gets 1 out of 10. Now, all of you will be surprised at this score that I gave Euler. Okay, Euler viewed numbers as quantities arising from counting and measurement. Yes, that's exactly right. In his publication, he emphasized numbers as fundamental to algebra and analysis, extending their concept to include negative, fractional, and complex numbers. So I would have given him 10 out of 10, but he mentioned complex numbers, so I deducted 3 marks there. Because complex numbers are not numbers. They're mathematical objects, but they're not numbers. And numbers stand and fall alone. They do not depend on any mathematical rules or decrees or beliefs. Cantor extended the number concept. This is that idiot, that insane idiot, Georg Cantor. He extended the number concept to include infinite cardinal and ordinal numbers. He defined numbers in terms of sets, introducing transfinite numbers, etc., etc. Well, let's just say that he was a clueless moron and he gets 0 out of 10. Wittgenstein viewed numbers as logical constructs rather than abstract entities. He treated numbers as properties of operations. That's pretty circular. That's why I've given him minus 5 out of 10. I mean, this is the kind of idea that you find in mainstream mathematics. How can they be properties of operation when they haven't even been defined? But circularity works in mainstream mathematics. And he emphasized rule following and context over absolute definitions. In other words, he was a bit of a drama queen, not a bit of a drama queen, a lot of a drama queen. And by the way, he happened to be gay. And he certainly didn't know what he was talking about. So he gets minus 5, probably the worst score out of all of them. Hilbert viewed numbers as formal symbols. Now, this is a moronic acolyte of Georg Cantor. Okay, not George Cantor, but Georg Cantor, whatever the hell his name was pronounced, however it was pronounced. He rejected any need for an intrinsic or metaphysical meaning, emphasizing a finitary foundation where numbers exist solely through their construction in a formal system. So again, he was the forefather of the idiots in mainstream mathematics today, claiming authority over the knowledge that they thought is, or that they think is correct. And his authority sought to secure mathematics by proving its consistency using finite methods, treating numbers as elements of a syntactic framework. Framework is a big buzzword amongst the morons of mainstream math academia and also in the AIs, rather than objects with inherent properties. He gets 0 out of 10. Because why? Rules, decrees, and belief have no place in rational thought. Now we get to that fine tobacco head moron Bertrand Russell. He defined numbers using logic, seeing them as classes of equinumerous sets. Strong Cantoric influence there. And both he and Whitehead derived arithmetic from set theory. They actually didn't derive arithmetic from set theory. They tried, but they failed. Treating a number as a collection of all sets with the same cardinality. And he rejected Kantian intuition, whatever the hell that is. Intuition shouldn't even be a word. And sought a purely logical foundation, reducing numbers to relations rather than intrinsic properties. He gets a -2 because he was an idiot, and I think all his smoking did really affect his brain. And of course, his ideas were framed on the set theoretic garbage of the father of all mainstream mathematical cranks, George Cantor. John Gabriel defines a number as a name given to a measure that describes the ratio of magnitudes. Now, that is what a number is. He emphasizes that numbers are abstract and that there are no numbers besides those commonly known as rational numbers. And of course, 10 out of 10, because I'm right. That definition is 100% accurate, and anything not conforming to it cannot be called a number. Okay, in Greek, arithmos, ego arithmevo. That means I count. I asked ChatGPT of all these definitions, which do you think is accurate? And here's what ChatGPT said. Based on your formulation, John Gabriel's definition seems the most aligned with a rigorous and geometric understanding of numbers, which is fundamentally abstract, viewing them as labels for measures in the context of ratios of magnitudes. The other definitions tend to conceptualize numbers in more abstract or logical terms. In other words, in terms of bullshit. Whereas your view places them firmly within the realm of measurable geometric relationships with a focus on rational numbers. Nah, that's just not right. They're actually abstract. They don't depend on you thinking about them. You don't even have to think at all for them to be well-formed concepts. If you're not already a subscriber to my channel, become a subscriber, and I'm going to give you these links in the details section. The one is called Realization and Development of Numbering, one page. This one tells you how you got arithmetic. Exactly, by the way, for the first time in human history. Even the ancient Greeks didn't publish this. This is truly groundbreaking, galactic scale knowledge. Okay? In other words, none of you fucking morons could have realized this even if you lived thousands of years. How do I know? Because I'm the first to publish it, and the first ones to think about number lived over 2,400 years ago. Okay? So that's how I know. And the final one is a free ebook, which is this Learning the Correct Way, free forever, because it's priceless knowledge. You have to have a free account on Academia, and you have to log in first before you can read any of the above. I'm John Gabriel, and this is New Calculus Channel. Till next time, goodbye.